voluntary. We are going to be working today on Lagrange multipliers. It's going to be a pretty long day as well, so hopefully you can hang in there. These Lagrange multipliers is a technique. It's quite a magical technique. We don't explain, nor would I even try to, why this method works, but it works. And what does it do? Well, it allows us to find the absolute maximum and absolute minimum of some function, you know, like z equals x cubed plus 5xy, right? Some function of x and y, subject to a constraint. So not only are you going to find the absolute maximum and minimum value of a function, you can only choose from whatever the constraint is. And this constraint is typically written as another function g of xy equals 0. So what would that look like as a real question? So here's a simple question that's similar to question 1, where it's asking us to find the absolute maximum minimum of this function subject to this constraint. So you're trying to find the biggest value for 3x squared y, but x and y must have this property that that guy squared plus that guy to the 4 is 5. Now, if you drew that, it would look like some kind of weird, distorted disk, right? Be all the points in a big blob like that. So you're trying to find the maximum and minimum value of this expression subject to that constraint. And Lagrange multipliers were created by this guy, Lagrange. It gives us a method of doing it. So let's put you right into the puzzle. Step 1. Lagrange found out that the places where this is true, right, where you can find this answer, you get them by solving this equation. The gradient of f equal to some number lambda, they typically use lambda, the gradient of g. And so what you're going to do is basically set up a system of equations, and you're going to solve that system of equations, right? You're going to find x's and y's at work. And those particular combinations of x and y's that solve this puzzle, that's the only place where the maximum and minims live. And so what you then at the end will do is you'll evaluate the original function at maybe 4 or even 6 different points. And the biggest answer is the absolute maximum, and the smallest answer is absolute minimum. Now, the method I'm going to show you is different, and I think better than other methods that you might see online. But feel free to go online and find the other ways to do it. And if you like that method, use it. So let's start by finding the gradient then of f. Now, do you see this guy here? He is the constraint function g of xy. So if I just rearrange this guy, g of xy ends up being this fella. Right, so if you move that over, this whole thing equals 0. That's g of xy. So this is the system of equations we're going to be solving. The gradient of f is lambda times the gradient of g. Now, the gradient of f is the partial derivative of this guy with respect to x, which is what, 6xy. And then you do it with respect to y, and you get 3x squared. Then you stick a lambda in, and you differentiate this function here with respect to x, and you get 2x. And this function here with respect to y, and you get 4y cubed. Are we good so far, guys? That you will solve this equation, right? You'll find the places where the max and min live by solving this system of equations, that the gradient of f is equal to lambda times the gradient of g. So far, so good. Now, if you match the x and the x together, you will find out that 6xy, this component, is lambda times that guy, so that's 2 lambda x, and I'm going to call that equation 1. And if you match the second to the second, you're going to get 3x squared is 4 times lambda times y cubed. And I'm going to call this guy 2. Now, at this point onwards, the method I'm going to show you, and the one that you might see in other videos, differs quite a lot. This is me moving on to step 2 then. So step 1, to set up the equation and generate 2 equations, in this case with x's and y's. Now step 2 is kind of the solving, and it's an unusual kind of solving. What I am going to do here, right, is I'm going to take equation 1 and equation 2, and I'm going to work with them. Now, if you look at it in detail, there are 3 different variables here. There's an x I don't know, there's a y I don't know, and there's a lambda I don't know. But there are only 2 equations, which means you cannot solve this in the usual way that you could algebraically, because according to the math world, you've 3 unknowns, you need 3 equations to solve. And you might think that's the end of the line, but it's not. Step 2, the first thing I'm going to do is I'm going to test what the answers look like when lambda equals 0. 9 times out of 10, when you make lambda equal 0, you're going to get a solution and it's not usable. Well, that's great, because that's you found out, you know, part of the puzzle is to find out what you can't use as well, right? But secondly, if you never test lambda equals 0, even although 9 times out of 10 it doesn't matter, do you know the one time you forget to check it is the one time it did matter? That's Murphy's Law. So I'm going to be doing these all day today, and you're going to say, how come none of them work? That seems like I'm putting a lot of work in. I guarantee if I stop looking, the next one is the one that does work and I miss one of my possible choices. Because my goal is to find any combination, any pair of values, x and y, that this is true for, right? That's going to maximize that guy. So let's make lambda equals 0. Equation 1 becomes 6xy equals 2 times nothing times x, which is nothing. I'll call that equation 1. And then the second one is 3x squared equals also nothing. Now, I'm going to try and see if I can find solutions to this problem. Right? So, if you use equation 2, 3x squared equals 0, then the only way that's going to happen is x equals 0. Would you agree? Yeah. X equals 0. Now, if x is equal to 0, does that have any effect on what's going up here? Well, if you take equation 1, 6 times 0 times y equals 0. Oh, I guess I found one of the 10 that really does work, right? So I can tell you right now that you can choose any solution, right, where x is 0. Right? So x could be 0. Right? And y can be anything you like, because 6 times nothing times y will still be 0. So I now go to my constraint, and I have x squared plus y to the 4 equals 5. And if x is 0, that means 0 plus y to the 4 can be equal to 5. And that makes y to the 4 equal to 5. And that makes y the 4th root of 5. And technically speaking, plus or minus the 4th root of 5. So I have got solution 0, negative the 4th root of 5, and 0, positive the 4th root, positive the 4th root of 5. By the way, these questions are huge. So, yeah, I'll put that around a little bubble. Let's go back to these 2 equations. If 6xy equals 0, couldn't that also happen when y is equal to 0? And does y equals 0 affect this? Well, if y is going to equal to 0, this will only be 0 when x is equal to 0. So that is another possible solution. So let me go through that again. I'm trying to solve this, and I'm assuming then that y equals 0 would make that work. Right. I then check out the second equation and say, okay, then, if y equals 0 makes this work, what does x have to be to make this work? And the answer is it has to be 0. So let's check our constraint. Is x squared plus y to the 4 equal to 5? Is 0 squared plus 0 squared equal to 5? No, it's not. That means that guy's not a usable solution. So all I've done here is made lambda equals 0 and try to solve the two equations that get generated from them. And what we got out of it was if x is 0 and y is this ugly guy, and x is 0 and y is that ugly guy, we can get places where the solution lives. On the other hand, if you had both of them 0, it fails under the constraint, right? This is not true. Well, that's step 2 done. Step 3 is now test lambda not being 0. Basically, find all the other solutions. So I'll just write down my two equations again. There's equation 1. And then I'll write down my second equation. And now I'm going to take equation 1 and divide it by equation 2. So I'm going to get 6xy all over 3x squared equals 2 lambda x all over 4 lambda y cubed. And you're always going to take equation 1 and divide it by equation 2 when you get to this step. Right? So not a kind of sometimes you do it and sometimes you don't. Right? Now I can simplify that a lot. One of the x's cancel, the 6 and the 3 partially cancel, so I get that guy on this side. That and that partially cancel. The lambdas cancel, and I get x over y cubed. Now, if I do a little cross multiply, I get 4y to the 4 is equal to x squared. And that gets me y to the 4 is a quarter x squared. So there's the connection between the x's and y's. Y to the 4 has to equal 1/4 x squared. And when you do these, you're not going to get x is 4 and y is 2. What you're going to get is something to do with y is equal to something to do with x's. Now, if you want me to take that all the way to the end, I could write it down that way. That y is 1/4 root of a quarter x squared. Now what you do is you substitute this y into the constraint to see what x would have to be in this case. Right, so here goes. I have x squared plus y to the 4 equals 5. So that means x squared plus this guy raised to the power of 4, which basically gets me 1/4 x squared. Are you okay with me just taking that to the power of 4 and writing it down, save a line of working? If this is y to the 4 basically gets you that. Now I have 5/4 x squared. That makes x squared. What does that make x squared? Oh, makes x squared 5. Right. Divide both sides by 5/4, which is multiplied by 4/5, which makes x plus 2. It also makes x -2. Oh, and by the way, when I go to here and here, you make that plus minus. Right. If x is equal to, let's say, plus 2, y will equal plus or minus the fourth root of 1/4 times 2 squared. Y will be plus or minus the fourth root of 1. Y will be plus or minus 1. So there's one of my solutions. And there's the other one. Now if I then use what happens if x is -2, y is plus or minus 1/4 -2 squared. It ends up fourth root of 1, which means it ends up being plus or minus 1. And so we now get the x could be 2 and 1, and x could be -2 and -1. So step 3 is make lambda, assume it's not 0, divide the 2, find a connection that has y in terms of x, use it in your constraint, and solve. So step 4 coming up. And in step 4, you take every solution that you have found. So I found a solution 0, negative, that fella. I found is 0 plus that guy. I found, who did I find? Oh, I found that guy. I found that guy. I found that guy. And last but not least, I found that guy. So the answer that we are looking for is going to come from these 6 guys. So what you do is you find the value of the original function at these points. And the answer that's the biggest, right? Oh, by the way, that one's 0, trust me, that one's 0, and I guess I should put what f of x, y is, because it's easy to forget what it's equal to. And I've kind of cheated here by doing these guys, so I have a plus or minus 2 minus 1. So this guy here is minus 12, this guy here is minus 12, and this guy here is 12, and this guy here is 12. Can you trust me? I just evaluated them all and we got what I said I did, right? Now, our answer's in front of us. The question was, what is the absolute maximum value? The absolute maximum value is 12. And I don't care that it happened to happen twice or 4 times. It don't matter. The absolute maximum is 12. And the absolute minimum? Well, the absolute minimum are these guys, since they're both the same. And that makes this one -12. Now you might think about, well, what about these 2 guys here? Well, the only answers I'm interested in is the biggest and the smallest. I'm not interested in any answers that happen to be, you know, somewhere in the middle. They're kind of boring. I don't care what they are. So I'm not even going to reference those 2. And that's the process from start to finish. It's got a 4-step thing. And just to show you, there's the question I just did. Can you see the answers are 12 and -12, like I said? So this method does work. As cumbersome and as big as it is, it works. But you're not going to get too many in $1, right? They're going to be quite a lot of work involved in them. Anything about that first example, right? The 4 steps that were used that you'd like me to talk about again, or you want to just wait till I do another one and maybe that'll get answered in the process? John, you did this one. The video that you were talking about, is it a video that did the divide like I did, or was it a video that showed you how to solve in a different way? I can't hear you. You must be muted. So you were saying, John?
Yeah, they solve differently. So the way they did it, they found the gradient, and then they set the gradient of G or F and G equal to each other with lambda.
Right, that's the same.
Yeah, and then they distributed lambda.
Right.
Solved for X, Y, and Z, plugged it back into the equation, and found values for that, and then plugged that back into the original equation.
Right,
And
so they
that's what it-
finished the same and they started the same, but the bit in the middle was quite different.
Yeah.
You've seen the one I've done, you've seen them, and I won't be offended. Did you like the other way or this way, or you don't care?
No, this way I think it's better. It
Okay.
kind of follows what we did previously. So
Good. So I will stick to that method then. Right, so here is our next question. It's similar to question 3. We're being asked to find the absolute maximum and minimum, as you're going to be for all these questions. And this time it's 3x e to the y. And the constraint is that the answer has to lie on a circle x squared plus y squared equals 2. So the gradient of f is going to be lambda times the gradient of g. That's basically my step 1. The gradient of f is those guys. And the gradient of g is those guys. Okay, differentiate this with respect to x, you get 3e to the y. Differentiate this with respect to y, and you get 3x e to the y. Equal to lambda. This guy gets you 2x, and this guy gets you 2y. When I look at g, I just basically forget about the number. And the reason I can forget about the number is, since I'm only going to differentiate the thing, don't the x's and y's are the only thing that matter. Technically speaking, it should be x squared plus y squared minus 2, but even if it is, that's still the derivative, so you're good. Now let's match them up then, which is essentially where we should be in the next part of our process. So I have 3e to the y is 2 lambda x, I'll call that equation 1. And I have 3x e to the y, and that's going to be 2 lambda y, and I'm going to call that equation 2. Things looking good? So let's move on to step 2. Let's assume that lambda equals 0 and see if we get any solutions out of it. Well, if you take equation 1 and you make lambda 0, you get 3e to the y equals 0. And if you make that lambda, you get 3x e to the y equals 0. And I can tell you right now, there is no way, no value of x and or y that is going to make 3e to the y equals 0. Would you agree 3e to the y is never equal to 0, right? It's always slightly positive at the best of times. So that is good news, because it means I don't have any solutions to worry about. And that's typically what happens when you do lambda 0, right? You don't get solutions that are usable. But I got lucky or unlucky. The first one I did, because it did actually generate some numbers. They just weren't useful. So we'll move on to our next step. And we'll assume then that lambda is not 0. And we'll take equation 1 and we'll divide it by equation 2 and see what we get. Well, we'll get 3e to the y over 3x e to the y, and it's going to be 2 lambda x all over 2 lambda y. And then I'll simplify it. Oh, the e to the y's cancels and the 3's cancel, so you get that. The 2's cancel and the lambdas cancel, and you get that. Now, you know, when you do these guys, you're never going to get x is 2 and y is 4. What you're going to get is y in terms of x, right? Some combination of the two. If I do a little cross multiply, are you comfortable that y equals x squared is the relationship between the two?
A question.
Yes.
For step 3 is equation 1 over equation 2.
Mm-hmm.
Is that just is there a reasoning behind that, or is that just?
Yes. The reasoning behind it is if you take equation 1 and divide it by equation 2, aren't you always going to kill off the lambda? And that means you're only going to be left with the variables, which is fine, because what you're trying to do is get a connection between the variables. You don't want a lambda floating out there, because that's just going to screw up the algebra. You won't be able to get out of the, well, I have two things that I don't know, and how am I going to deal with that, right?
And since we're dealing with a system of equations, dividing them like this is something we can do and work with.
It's something you can do, and another reason we can do it is, since lambda is not 0, isn't it okay to divide things? So we have this guy. Well, our constraint is that x squared plus y squared equals 2. Well, if you tell me that y is equal to x squared, then I now can write down x squared plus x squared squared is 2. And that ends up getting you x to the 4 plus x squared minus 2 equals 0. Are you comfortable with where I am right now? Taking the constraint, replacing the y with x squared, and then just tidying up a little bit. Now, if you do things correctly, you'll be left with an equation with just one variable in it, typically x. And now that means it's solvable. It would be nice if it was 2x plus 1 equals 10, right? Nice, easy solvable, but it's probably not going to be that. But this can be done. And I'm going to do a little sneaky algebra. If I told you that z squared plus z minus 2 equals 0, just randomly told you that, and I said, I'd like you to find out who z is, I hope you would say, well, it's just a quadratic. And since you're looking for two numbers, one is positive and one is negative, you would do that, right? And now you could say z is 1 and z is negative 2. This guy is much closer to that guy than you think. I want you to think of z like it was x squared. So this guy can be factored. It's x squared times x squared. It's a plus 2 and it's a negative 1. Do you see I've just factored an x to the 4, which is definitely something new for us. We know how to factor quadratics, right? But guess what? Sometimes you can factor quintics, right? 4th powers. Are you comfortable with this becoming that? Does that make sense to you? Right. It's just a little algebra trick that I've now showed you, so you might want to use it sometime in the future if that happens again. Right. So provided you have got 3 things, it's a trinomial, you should be able to factor it if it's factorable. Now let's solve. Well, according to this factor, x squared plus 2 would be equal to 0, and according to this one, x squared minus 1 should be 0. Well, guess what? That's impossible. You're never going to get x squared plus 2 equal to 0, right? X squared is positive, right? Add 2 is still positive. On the other hand, this guy gets us 2 answers. Negative 1 and 1. Well, if you take x equals negative 1, y is x squared. So that makes y negative 1 squared, which makes y 1. So I've got my first possible place. And when x equals 1, y is still equal to x squared. Y equals 1, and I have got my second answer. So this one went a little bit smoother. Do you see that there's only 2 places to go looking? Right? That's the only 2 solutions that ended up being usable. So for our final stage, we'll take the original function, oops, xy, take the original function and evaluate it at -1, 1, and evaluate it at 1, 1. And whatever one of these two guys is the biggest is the absolute max, and whatever one of these guys is the smallest is the absolute min. So let's see what we get. We get 3 times -1 times e to the 1, which is -3e. And this guy gets you 3 times 1, e to the 1, and that gets you 3e. Yep, we got it. There's your absolute max. It's that number. And there's your absolute minimum. It's that number. Okay, now you've seen 2 of these. Are you beginning to see a type of flow to the process? Because it is a process and there's lots of stages, right? There's 4 steps and there's a lot of little details where things, a plus could turn into a minus by mistake, that you have to be on top of. Otherwise, you could do 90% of it right and still not get the answer at the end. Okay, this one's done. Any questions about it before we move on?
Is it surprising that the max and min are symmetrical?
It's not that surprising. You'll find that that's kind of common. So when you do these kind of questions, you tend to get things like ±2 for the x, ±3 for the y. So, right, so there tend to be a kind of, you know, similar numbers, maybe different signs that generate 4, 6, 8. I've seen 8 in some of these questions, right? 8 possible combinations. So it's very common.
Thank you.
So can move on. Right. Here's we go with the next one. Okay, this is a version of question 4. Oh, well, should check what I just said. And it was correct. I've just checked the solutions in WebAssign. So in this one, we're going to do a function xy, and it's maximize and minimize this function, subject to the constraint that x to the 4 plus 3y to the 4 equals 2. Okay. Start with step 1. Gradient of f is going to be lambda the gradient of g. Partial derivative of x and y, lambda partial derivative x and y. And just like I did last time, can't we just pretend that guy's the g of x, because it's going to be anyway. So differentiate with respect to x, you get 4x. Differentiate this with respect to y, you get 12y. Lambda. Differentiate this with respect to x, you get 4x cubed. Differentiate this with respect to y, and you get 12y cubed. Be comfortable with that guy? Right. If we match them out then, 4x is going to be 4 lambda x cubed. 12y is going to be 12 lambda y cubed. And there's my equation 1, and there's my equation 2. And that's step 1 finished, right? We've set up the system. We've found the first and, you know, the 2 derivatives, matched them out, 2 equations. We are good to go. So step 2, let's look at, is lambda equals 0 going to give us a solution? Well, if you plug in lambda equals 0 here, you get 4x equals 0. And if you do it in this one, you get 12y equals 0. Well, if you're trying to find out when is this true, would you agree that it can only happen when x is 0 and y is 0, right? Now, that might be usable, but let's check it out. According to the constraint, x to the 4 plus 3y to the 4 must equal 2, or you're not a usable solution. Well, 0 to the 4 plus 3 times 0 to the 4 is definitely not 2. So, as I would expect, it's a non-usable answer. Right? Can't use it. It doesn't satisfy the constraint. Let's move over to step 3. We're going to assume that lambda is now not 0. And I'm going to take equation 1 and divide it by equation 2. So equation 1, 4x over 12y equals, right, 4 lambda x cubed over 4 lambda y cubed. And I can cancel a little bit here, and I have x over 3y. I can cancel the 4s, and I can cancel the lambdas, so I get x cubed, I get y cubed. Things looking good so far? Now, if you do a little cross multiply, you get 3yx cubed is equal to x y cubed. Now, I'm trying to find a relationship where y in terms of x. And right now, I don't think it's a good idea to start dividing both sides by x or divide both sides by y. And the reason for that is that one of them might be 0, in which case I'd be doing some bad math. So I'm going to have to take it the slower way. Then I'm going to pull out an x and a y as a common factor. Okay.
For equation 2, why is it 12y and 4 lambda y cubed?
I hope I wrote it down. I didn't, did I? Well caught.
Sorry.
No, I'm glad you got it. I missed it. So that means what's this going to be? What, 3 on the bottom? But let me just redo it from scratch. That is a classic example how a little detail can screw up the whole process. Because if I continued with what I thought was correct, I might well get values of x and y, but they would not be correct, and my solutions would end up being wrong. Right, so that's the corrected version. I can still get x over 3y, which I like. I can get, well, lambdas cancel, and not so much, but I get x cubed over 3y cubed. If I do the cross multiply, I get 3x y cubed equals 3y x cubed. If I bring them over here, okay, it's a little bit different than it was a minute ago, agreed? Now, if I pull out 3x and y as a common factor, I'm left with that. And our goal is to have relationships, right? Connections where y is in terms of x. Now, I'm going to forget about these guys until the end, and I'm going to focus on this one. If these things all multiply together give me 0, and this is one of the factors, then this is a possible solution. In other words, y squared could equal x squared. Are we good with that? And if I rearrange that, basically y is plus or minus x. And I'm going to use that relationship with the constraint now. So x to the 4 plus 3y to the 4 has to equal 2. So x to the 4 plus 3 times. Well, if you put x or negative x in there, it really isn't going to matter because the same answer is going to pop out. You're going to get x to the 4 plus 3x to the 4 equals 2. And that's going to give me 4x to the 4 equals 2. That's going to give me x to the 4 equals 2. And that makes x plus or minus the 4th root of 2. Now, if x is negative the 4th root of 2, y could also be that guy.
Is it 2 or is it 1/2?
I am old. It is a half. Fourth root of a half, y equals plus 4th root of a half. Darn it, space, that's a lot of work. And do I have any other combinations? Yes, I could have positive, so I get a plus version of the 4th root of a half. And y ends up being the negative 4th root of a half or positive 4th root of a half. In other words, there are 4 different solutions here. And like you were mentioning earlier, John, isn't there an awful lot of pluses and minus symmetry thinking on here?
Right.
Which is very common. Now, I could, I guess I should, write down each one of them as a real coordinate. So that's one of our possible guys. This is another one. And another one, another one. So there are the 4 possible guys. Now, I said I'm going to ignore these guys. Let's not ignore them now. If you want this to be equal to 0, x could equal 0, y could equal 0. Agreed? X could be 0 or y could be 0, right? That would solve this equation. So I'm now going to do x equals 0. I'm going to take the constraint, which is x to the 4 plus 3y to the 4 equals 2. If x is 0, you get 3y to the 4 is 2. You get y to the 4 is 2/3. And that makes y plus or minus the 4th root of 2/3. So that means I get the answer 0, 4th root of 2/3, and 0 minus the 4th root of 2/3. If I then go and I make y equals 0, can I just cut to the chase here? You end up with, oh, let's just do it. If I make y 0, you get x to the 4 equals 2. That makes x plus or minus the 4th root of 2. So you're going to get negative the 4th root of 2, 0, and positive the 4th root of 2, 0. God in himmel, this is ridiculous. I got 2 possible answers there. I get 2 possible answers there. And we got 4 more here. In other words, there are 8 different places to go looking. So the original function was, what was it? 2x squared plus 6 plus 6y squared. There are 8 possible places. For instance, just at random, one of them would be negative the 4th root of 2, comma 0. Another one of them might be negative the 4th root of 1/2, negative the 4th root of 1/2, right? There are 8 of those guys. What I could do now is evaluate the function at all of those 8 places. And if I did it correctly, I will have, and I think we've caught all the mistakes, we will have, and let's check what it says the answer is, that the maximum value ends up being 4, and the minimum value ends up being 2. And can I tell you where they happen? Right. Do you see all those plus or minus 2 guys that we got? Right. So all the functions that had plus or minus 1 over root 2 and 4th root, whatever it is, and plus or minus 1 over root 2, that's where the 4s came from. And the other ones came from the other constraints.
Can you show the page
That-
where you plugged in x equals 0 again, please?
X equals 0. Here we go. And what you're really dealing here with is 8 answers. And it's really just a matter of calculating what that is equal to. And evidently, the biggest answer is 4, and the smallest answer would be 2. And that's pretty much it. Okay, I'll give you a few seconds because some of you sound like try to keep track of all the working in that one. I did not like that question. It was ugly numbers and it was huge. I much preferred the one before it, which came out kind of clean. But you don't know what you're getting until you get there. Okay, we're ready for the next guy. And the next one is a version of question 6. And we're increasing the number of variables. We're trying to find the maximum and minimum value of this function, subject to constraint. And the constraint is that x squared plus y squared plus z squared equals 64. Now, when you increase another variable, you do have to adapt. So, step 1 is the gradient of f is still going to be lambda times the gradient of g. The only difference is that f has now got 3 pieces to it instead of 2. And the same thing's true about g. It's going to have 3 pieces to it. It's a bit like adding an extra dimension. So, if you do the partial derivative of this guy with respect to x, you get y squared z. If you now do it with respect to y, you get 2xyz. And if you do it with respect to z, you get xy squared. If you do this one with x, with y, and with z, you get that guy. So instead of 2 equations, we're now going to get 3. If you match the first terms together, y squared z is going to be 2 lambda x. 2xyz is going to be 2 lambda y. And lastly, xy squared is going to be 2 lambda z. And I'm now going to call them equations 1, 2, and 3. Are we okay with the expansion of this? Right, from 2 to 3. Same idea, just a little bit more work, right? Theoretically, you can expand it to 20 dimensions, but nobody's going to do 3 more than 3. It's just too much work. Are we good? Right. Step 2 is, what would happen if lambda was 0? Well, you would end up with y squared z is 0, 2x, y, z has to be 0, and x, y squared equals 0. Are you comfortable with that connection, right? Now, although it looks messy, it's actually not that difficult. The only way this is going to be true is if all three of them are 0. Would you agree? You need an x 0, you need a y to be 0, and a z to be 0, right? You wouldn't be able to do every combination. Just trust me, 0, 0, 0. Now, does that work for my constraint? Well, according to the constraint, x squared plus y squared plus z squared should equal 64. And that's not going to work. I'm just checking my answers here if I can. Because 0 squared plus 0 squared plus 0 squared is not 64. So forget it. Well, what does step 3 look like? Well, we assume that lambda is now not equal to 0. And I'm going to take equation 1 and divide it by equation 2 like I always have. And that's going to get me y squared z over 2xy z. And it's going to equal 2 lambda x over 2 lambda y. And I'm going to tidy that up. Well, the z's cancel, one of the y's cancel, and I'm going to have y over 2x, and that, and I'm going to have x over y. And with a little cross multiply, can't I say that y squared is 2x squared? And if you want to, you can call that y is plus or minus the square root of 2x. So that's good. But I can't use that in the constraint yet. And the reason I can't use that is there's 3 variables. And right now, even if I replace the y, I'd still have some z's floating around and I wouldn't be able to solve it. So what we now do is take equation 1 and divide it by equation 3. And on the top, we get y squared z, and underneath it, we get x y squared. And it's going to equal, on the top, 2 lambda x, and on the bottom, 2 lambda z. And the y squares cancel, and you get z over x. And the 2's and the lambdas cancel, and you get x over z. And a little cross multiply, you get that. Okay, I'm just making sure I didn't screw up here. And so won't that be z equals plus or minus x, essentially? Now I can take the constraint and use these guys to turn everybody into an x. So I have an x squared plus a y squared plus a z squared has to be equal to 64. So that's x squared plus this guy squared plus this guy squared. Now, if you notice, if you square things, pluses or minuses become positive, and I get this, which means that I have 4x squared is 64, which means I have x squared equal to 16, which means x is what? Plus or minus 4. Now, if x is plus or minus 4, won't y be plus or minus the square root of 8, right? 2 times 4. And won't z be plus or minus the same number that x is? So plus or minus 4. So what I'm trying to do here is just write a condensed version of all the combinations. If you think about it, 2 times 2 times 2, won't that be 8 combinations? Right, and the 8 combinations would look something like this. A 4, well, actually, I could call that 2 root 2 because it looks nicer, right? a 2 root 2, and a 4. And then if I did a -4 with the same two guys, then I could do a 4 and make the middle one negative, and a 4 and make the middle one positive. And then I can do a 4 and make the last one negative. Try to go through every combination I can think of. Well, actually make that negative as well, and 4, make that one negative, and that one positive. And I'm getting kind of lost because I think I'm duplicating. So, to save time, can you imagine I took every one of these combinations and I found the value of the function? There's going to be 8 altogether, right? 2 times 2 times 2. And when you do the combination, well, I can't tell you on this one because it's not the same answer. What one was this? 6. No, it's not the same question anymore, so I can't do the answer. The one I've got 64 and they have a different number. So let's just pick one at random. This guy here would be 4 times 2 root 2 squared times 4. And I think that actually would be the biggest because it would be 4, 4, 4, be 128. And if I picked this guy, I would get -4 2 root 2 times 4. Oh, and that'd be -128. There, I got my two answers. I bet you all the other ones would either end up being plus 128 or minus 128. Right, so I know the max is 128 and the minimal is -128. So evaluate every single combination and you will find out that one of these is a positive and the other one ends up being a negative. And since they're essentially using the same numbers, can you see you're going to get 128 of some kind out of all of them? Okay, how are we on that one? If you expand to 3 variables, do you feel good about it?
There's a lot of arithmetic that adds up real fast. with that.
Oh God, it does. You're going to have to be on top of things as far as just being careful. It's not my strong point, but I'm comfortable with that. I'm sure it's right. Okay, you ready to move on to the next one? Yep. Okay, so the next one is going to be another 3 variable. You don't get a lot of them. And so that's going to be question 7. And I do have the solution in front of me here, so that's going to at least make some of the work go quicker because I'll just tell you what it is. So we are trying to maximize x squared plus y squared plus z squared. And it's going to be subject to a constraint that x squared plus y squared plus z squared plus xy equals to 27. God, that looks weird. Okay. I'm going to go and do the gradient of f, and it's going to be equal to lambda times the gradient of g. Okay, you do this guy with x, you get a 2x, you get a 2y, and a 2z. At least that's nice. This is not so nice. You're going to get lambda. If you do this guy, you're going to get a 2x plus a y. If you do it with respect to y, you're going to get 2y plus an x. And if you do it with respect to z, you're going to get 2z. So if we match the first with first, 1, 2x is going to equal lambda times 2x add y. That's equation 1. If you do the second one, you're going to get 2y equals lambda 2y plus x. It's going to be equation 2. And if you do the third one, you're going to get 2z is equal to lambda, 2 lambda z. How are we doing, guys? Are we good? Right. Let's assume that lambda is equal to 0. If lambda was equal to 0, are you happy that that's what happens? And the only way that's going to be true is 0, 0, 0. And can I do a quick in my head check? Would you agree that doesn't equal 27? So 8 working, 9 times out of 10, it never does. So far, so good. Right. Now, we're going to take equation 1 and divide it by equation 2. So that is going to be a 2x over a 2y is equal to a lambda 2x add y over a lambda 2y add x. The x's cancel, or the 2's cancel, and you're left with x over y. The lambdas cancel, and you're left with that guy. First thing I'm going to do is cross multiply. Then I'm going to distribute. And then I'm going to say, thank you for being nice to me. Can you see the 2xy's basically cancel out? And we are left with y squared equals x squared. And I will transfer that into y is plus or minus x, which is good news, right? We've now found that y is in terms of x, and that's our goal. Now, isn't our next goal to get z in terms of x? Right? So, take equation 1 and divide it by equation 3. So we're going to have 2x over 2z. And it's going to equal lambda 2x plus y over 2 lambda z. So I'm going to have an x over z is equal to, and that's a nice here, it's going to be, that's cancel, oh, it's going to be 2x add y all over 2z. You agree? Only thing it cancelled here was the 2 lambdas. Now if I do a cross multiply, 2xz is equal to z times 2x add y. And 2xz is equal to 2xz plus zy. How are we doing so far? Now, those guys die, and we are left with 0 equals zy. It's a little bit different than normal. Okay, so it would be nice if I had z was equal to x, right? Or z was 2x. That would be great, right? But I don't get what I get, so I'm going to have to deal with that. So I'm going to work on this thriller first. The only way that could be true, or one of the only ways it could be true, is z could equal 0. Great. 2 things multiplied are 0. One possibility is z equals 0. The other possibility is y equals 0, right? And we'll take care of that later. Right, now if z is equal to 0, and this is true, because it still is, then my constraint, which I now can't find, is, oh, here it is. Our constraint is that x squared plus y squared plus z squared plus xy has to equal 27. Well, if z is 0 and y is plus or minus x, then y squared just gets you x squared. That guy gets you 0. And you have x times y here. And that's a little bit tricky because I'm going to have to choose one of the choices here. So I'm going to choose y equals x guy, and that makes this x squared, and we get 27. So that makes 3x squared 27, which makes x squared 9, which makes x plus or minus 3. So if I put that together, x could be 3, y is the same value, and z is 0. If I put -3, y is the same value, and z is still 0. Okay, I get two solutions out of that. Now, I'm going back to the z equals 0, and I'm going to do y equals -x. So x squared plus y squared plus z squared add xy is 27. Square that guy, you still get x squared. That guy gets you nothing. And x times that gets you a -x squared, which is 27, which means I now have x squared is 27, which means that x is the square root of 27, which is 3√3. And it could be plus or minus. So what does that mean? Well, x could be 3√3, y is going to be the negative of that, and z could be 0. X could be -3√3, y would be the negative of that, so it's plus, and 0. There's two more guys. So I have two possible answers, there's two more. And all I've done is start with this guy and say what could make it happen. Z equals 0 could make it happen. Well, there is another possibility. Couldn't it be y equals 0? But if y is equals 0, and y is plus or minus the x, then doesn't that make x has to be 0 as well? And that means that my constraint ends up being x squared plus y squared plus z squared plus xy equals 27. That's 0, that's 0, that's z squared, that is 0, and we get 27. Which makes z the square root of 27, which is plus or minus 3√3. So we get a solution 0, 0, 3√3, and 0, 0, -3√3, which is another solution. So we have 6 guys in town, and we are trying to find the maximum and minimum value of x squared plus y squared plus z squared, which is this guy. Okay, if you plug that guy in, you get 9, 9, so you get 18. Right, so I guess I should write them down. If you do 3, 3, 0, you get 18. If you do -3, -3, 0, you get 18. If you do 3√3, -3√3, 0, God in Himmel, you get 27. That's also 27, so you get 54. If you did this combination, you also get 54. And if you do this combination up here, you get 27. And if you, oops, that guy there. And if you do the last combination, which is this one, you also get 27. And did I do that correct? Yes, I did. Right. So absolute max, absolute min. And I just made the mistake there. Absolute max is 54. What is the absolute min?
18.
18. Okay, that one was a bit scary, wasn't it? There were, at the end of the day, there were 6 combinations that solved the constraint problem. And from there, we got the absolute max and min. But you don't get many of them to the dollar. So where are we off to next? Well, there are a bunch of questions that come next, which fall into 2 categories. The first kind are going to be word problems. I guess you'd call them applications. And the second one are constraints, that instead of being, you know, x squared plus y squared equals 9, they become x squared plus y squared less than or equal to 9, you know, typically less than or equal to. And so how do you deal with these new ones where the constraint is not equal to 9 but less than or equal to 9? And then we'll deal with the word puzzles. So let me do a quick scan through and I'll give you a list of the ones that fall into each category. So if you're doing word puzzles, 13 will be an example of that one. So is 14, I may have to word it backwards. 12. This guy's 11. 10. Kind of scrolling backwards, as I said. 9. And word puzzles, 8. So there's what, 7 more questions to cover. I think what I should do next is look at the ones that have constraints that are less than or equal to, right? And show you how you tackle them. The good news is there is no difference. You tackle them the exact same way, right? So let's pick one, 9, 10, or 11. Who am I picking? Let's pick 9. So an example of the constraint is a less than or equal to situation would be this one. Find the max and min, absolute maximum min, of x squared plus y squared plus 8x, take away 8y. And the constraint now is that x squared plus y squared has to be less than or equal to 81. Okay. So here's your first nice thing. Do you know the constraint function is still x squared plus y squared? It doesn't care if it's equal to 81, bigger than 81, or less than 81, right? The constraint function is still x squared plus y squared, right? So you don't need to change that. And you will solve it in the usual way, like that. Well, differentiate this with respect to x, you get what? 2x add 8. And with respect to y, you get 2y take away 8. Lambda, 2x, comma, 2y. Are we comfortable about the consistency? But I'm really doing nothing different here, right? Wouldn't I be doing the exact same thing if that had said equals 81, right? Now, if we match them up, we have 2x plus 8 equals 2 lambda x. And then we have 2y take away 8 is going to equal 2 lambda y. And that's going to be equation 1. And that's going to be equation 2. And I don't see anything really different yet. Hopefully neither do you. So far, so good. Step 2. Let's assume that lambda is 0. Now, if lambda is 0 here, we get 2x plus 8 is 0. And we get 2y take away 8 is 0. And if I do a little solution here, isn't that x is -4 and isn't that y equals 4? So that means we have a possible candidate. X is -4 and y is 4. And what I'm going to do now is plug it into the constraint. Well, the constraint says x squared plus y squared has to be less than or equal to 81. So -4 squared plus 4 squared has to be less than or equal to 1. Well, 16 add 16, 32. Ah, okay to use it. Hey, we've got an answer where lambda equals 0 was usable, right? Now, because it is less than 81, do you see why it worked? If it was equal to 81, wouldn't 32 fail? Right? It wouldn't be able to match the constraint. And that's step 2 done. Step 3. Let's assume lambda is not equal to 0. And I'm going to take equation 1 and divide it by equation 2. And I'm going to get 2x add 8 on the top. And I'm going to have 2y take away 8 on the bottom. And it's going to equal 2 lambda x over 2 lambda y. And you know, I could tidy that up, dividing by 2, but I'm just going to be lazy and not bother. I'm just going to leave it alone. It'll sort itself out in the next line or two anyway. X over y. Now I'm going to cross multiply, so y times 2x add 8 is going to equal x 2y, take away 8. And if you distribute it, you get 2xy plus 8y is equal to 2xy take away 8x, which means 8y is negative 8x, which makes y equal negative x. Oh, and to remind myself, that's a possible answer. And we like y equals negative x. Now, if I go back to the constraint, x squared plus y squared, and I know it is less than, but we are only interested in on the boundary value. So I'm going to get x squared plus x squared is 81. So I'm going to get 2x squared is 81. So x squared is 81 over 2. And that makes it plus or minus 9 over root 2. Now you might be saying, but the constraint is less than or equal to 81. Why am I not sticking a less than or equal to 81 here? Well, if I did that, you would find out that you wouldn't be able to get specific points. Wouldn't you be able to say x is less than or equal to some number? And kind of subtly, when you did the lambda equals 0 bit, you were actually finding all the answers that were inside. And when you do lambda not equal to 0, you're actually only going to find the boundary points. In other words, you're back to being equal to 81. So isn't that nice that it doesn't really change an awful lot? Now, I've got an x. It's plus or minus 9 over root 2. Let's see what the constraint says. The constraints, well, we've got x, right? So if x is plus or minus 9 over root 2, won't y be the negative of x? So that's negative plus, that's kind of messy. Okay, let's show you the 4 answers. If x is that guy, y is the negative of him. If x is that guy, y is the negative of him. There we go. 2 more solutions. So I'm going to find the value of the function at negative 4, 4. The value of the function at this point. And the reason I can only do 2 of these is whatever x is, y can only be the negative of it, not plus or minus. It can only be the opposite. And if it's this guy, we get that. And the function that we were trying to maximize was x squared plus y squared plus 8x take away 8y. Now, to speed up the process here, I'm going to tell you what the worst answer is, although I don't know which one it is. The smallest answer you will get from one of these is negative 32, and that's your minimum. And the biggest answer you're going to get is 81 plus 72 root 2. And we're going to call that the maximum. Now, I don't know which one of those 3 gets you that and which one of those 3 gets you the other, but if you plug them in, you'll find them. Right, can we just pretend that that one there gave me negative 32 and that this one here gave me the other answer? Okay, how are we with constraints that are less than or equal to rather than equal to? Would you agree that 90% of the process is the same? Right? Very similar process. Do you want, there's two more of those guys. Do you want me to do one more, or shall we move on to the application questions?
I wouldn't mind doing one more. I mean, I
Okay.
don't know what everybody else
Hey.
wants.
Yeah, if one person wants it, I guarantee there's 5 other people wanting it, so it's never a problem. Let's see, constraints 10, 9, 10, 11. So I forgot which one. I just did 9, didn't I? Okay. So let's see what 10 and 11 look like. Let's do 11. Looks the uglier of the two. We're trying to find the absolute maximum and minimum value of that guy, subject to the constraint that x squared plus 4y squared must be less than or equal to 1. So the gradient of f is going to be lambda times the gradient of g. If you differentiate this guy with respect to x, you do get e to the negative xy, but you get something else as well. If you differentiate e to the power of negative xy, what else do you get? Think chain rule. Differentiate, then side function, which is this guy. Last chance, what do you get?
Multiply it by the -1. So negative
Negative 1y.
y.
Yes. Right. If it was just minus x, it would be negative 1. You're right. And if you do the other guy, can you see you get a very symmetric looking answer, right? Now you put in a lambda, that guy is 2x and that guy is 8y. Now we set up the first equation by matching the first one with the first one, and it looks like 2 lambda x. And then you match up the second equation, and that ends up being 8 lambda y. Right, and that's equation 1 done, right? So, or not equation 1, but step 1 done. Right, now we make lambda 0. Well, if you do that, negative y e to the minus xy would be 0, and negative x e to the negative xy would also be 0. And we're trying to see, is there any solution to that problem? Is there any combination of x and y where this would be true? And I'm not going to do algebra, I'm just going to look at it and say, I can make a prediction here. Would you agree that x is 0 and y is 0 is the only one that's going to make that happen? So here's my argument. Isn't e to the negative xy never 0? So aren't you basically trying to solve when is negative y 0 and at the same time when is negative x 0? Isn't that only going to happen when they're both 0? Right, so that's kind of my solution. Now that may or may not be a usable one. So we have to go back to the constraint. And the constraint is that x squared plus 4y squared has to be less than or equal to 1. Well, 0 squared plus 4 loads of 0. Yep, you are a usable answer. Right, 0, 0 might be the place where the absolute max or min lives. Right, we got one check. Actually, this one is turning out to be a lot cleaner than I thought it was going to be. Now, step 3. In step 3, we make the assumption then that lambda is not 0. And we're also going to make the assumption is that we now are only going to be looking at the boundary. In other words, equals 1. Because lambda equals 0 took care of the inside points, right? And lambda not being 0 is going to take care of the boundary. So if I take equation 1 and divide it by equation 2, I get negative y e to that guy, negative x e to that guy, 2 lambda x's over 2 lambda. Oh, that's going to come out nice, isn't it? Won't these two cancel out? Won't the negatives cancel out? So I'm going to have y over x. The 2's and the lambdas cancel. I'm going to x over y. A little cross multiply. Isn't y squared going to be x squared? And that means that y can be plus or minus x. So there are going to be two choices. Right. Now I'm going to my constraint. So I'm first going to try out y equals x and see what we get. We get x squared plus 4y squared only needs to equal 1. So x squared plus 4x squared is going to equal 1. So 5x squared is going to equal 1. Do that guy. And plus or minus 1 over root 5. Okay, so if x is 1 over root 5, y will be the same, 1 over square root of 5.
Hold up, we have a mistake on step 3.
Oh, God,
1
no.
divided by 2.
What did I screw up?
Yeah, it should be 8 lambda y on the bottom on the right side of the equation.
Over here? Right, I've got 1 plus 4 is 1.
Equation 1 divided by equation 2, the right side, denominator.
Oh, God, yes, well caught. Okay, 8. That's going to change the world a little bit. It's going to be 4. That's going to get me 4y squared. That's going to get me y squared is a quarter x squared. And that's going to get me y is plus or minus a half x. Okay, I'm going to just forget that bit now because it's using wrong information. So when we did equation 1 by equation 2, we ended up that y is plus or minus 1/2 x. Okay, now go back to the constraint function. And I'm going to pick the positive answer, which is that guy. And now I'm going to do x squared plus 4y squared equals 1. And so that's going to be x squared plus 4 lots of 1/2 squared. Oh, that comes out nice. Get a different result, but also quite nice. Would you agree? 1 over root 2. So if x is positive 1 over root 2, y will be the same thing, but a half of that. So 1 over 2 root 2. And if x is negative 1 over root 2, y will be half of that, negative 1 over 2 root 2. So that's those answers. If I do y equals negative a half x and I go through that same process, can you trust me that x ends up being the exact same? And so that means that if x is 1 over root 2, y will be the negative of that doubled. And if y is, if x is the negative fella, then y will be that guy. So it looks like altogether there are 5 possible answers. You're going to get 0, 0. That guy. Did I duplicate these? Oh, I did. Looks like these two answers end up being the same as these two, so I guess I did duplicate. And what's the final result going to be? Well, since it's not that ugly a function, I think I might be able to get the answer. E to the negative xy. Right, e to the 0, 0 gets me 1. If you plug in one of these answers, evidently you get e to the power of a quarter. And if you plug in The other one, you get e to the negative a quarter. And so what we're looking at here is that guy is bigger than 1. So that's the max. And that guy is less than 1, so that's the min. And that guy's just a middle number that's no use. I would go with that. I mean, if you want to plug a number in, if you plug 1 over root 2 and you times it by 1 over 2 root 2, you get a quarter, right? Or you get plus a quarter. And I think I have 2 more combinations I probably should have put in. Okay, which combo? Negative. Oh, both of them negative. Okay. Right. Looks good now. So that guy's a plus. Those 2 are negatives. So I'll just move the minimum down. Still same minimum, just happened at a different place. Okay, how are we doing on this guy? Yeah, I get careless as everybody who's ever had been before, especially when there's a lot of numbers and you try to do things quickly. If you take your time, you'll have less chance of screwing up like I had. Jesse, question?
Yeah, can you briefly explain why we're not doing greater than or equal to what besides step 2?
When you do lambda equals 0, right? You're basically going to be doing the less than or equal to constraint, which in this case was whatever. I can't remember what the. Can we just pretend, for argument's sake, that the constraint was that, right? Just for argument, right? When lambda equals 0, you're actually solving all the points that are inside. In fact, you're actually solving all the points in the universe, which means you're solving the points inside. When you make the assumption that you've already taken care of the universe, except on the boundary, you're allowed to only fix now that guy. And so the logic says you can get away with that, which is kind of nice that you can. Because if it wasn't true, wouldn't we be trying to solve things like 2x squared is less than 9? Which means there wouldn't be a single value, wouldn't there be an infinite number of values of x, in which case, how could you solve the question? You need specific points. And the fact that this says lambda equals 0 takes care of the universe except the boundary, and lambda not 0 takes care of the boundary part, that's pretty much, it helps in the solution of the puzzle. Does that work for you, Jesse?
Yes, I kind of thought so. I just wanted to make sure. Thank you.
Okay. So what is left is applications, word stories. There are 4 of those. Let's do one with just combinations of numbers because they tend to be easier. So the one I'm going to do is 13. And it says, use Lagrange multipliers, like I wasn't going to anyway, to find 3 positive numbers whose sum is 190. So you have just told me that since their sum is 190, you have just given me the constraint. Right? 3 numbers and they must add up to 190. That is a constraint. And we're being asked to find the maximum product. So essentially, what's the biggest product? Well, if I call f of xy the product function, isn't the product function x, y, z? Are we cool with this? Right? So I'm trying to find the biggest value for x, y, z subject to this constraint. If you were a betting man, won't the answer probably be x is 1/3 of 190, y is 1/3 of 190, and z is 1/3 of 190? That makes sense just based on symmetry. But you can't always rely on symmetry to prove a question, so let's do the math of it. The gradient of f is lambda times the gradient of g. Once you have set up the question to have a constraint and a function that you're trying to find a maximum or minimum value of, right? You are now back to, our world, right? In fact, this one doesn't have to worry about negatives, so I'll put that out the side. And if you do the derivative of this y with respect to x, then the derivative of this guy with respect to y, and then the derivative of this guy with respect to z, you get that. Lambda times, oh, this is too nice, 1, 1, 1. Right, so it's not the worst looking one. Now that's going to match out as yz is lambda, xz is 1 lambda, and xy is 1 lambda. And that's going to be my 3 equations. Are we good? 1, 2, 3. That's step 1 done. Right, step 2. Let's do lambda equals 0. Well, if lambda equals 0, you end up with these 3 equations that need to be solved together. Would you agree that the only combination of x, y, and z that's going to make all of these 0 at the same time would be x, y, and z all being 0? And now I'll check to see if that's usable. Well, the constraint function says that they need to add up to 190. And since 0 adds 0 adds 0 is definitely not 190, you're no good to me. In fact, since there is only one maximum product, if I can find any solution, that should be the solution. So I don't expect to get 8 solutions. In fact, if I get 8 solutions, I'm going to be really worried. I much prefer that there's only one solution, and that's the guy I'm looking for. So that's what step 3 is going to be doing. And we're going to assume that lambda is not 0. And I'm going to take equation 1 and divide it by equation 2. And yz is xz. And it's lambda over lambda. And y over x is 1. So y equals x. Oh, that's cool. And now I'm going to take 1 and divide it by 3. And that's going to be yz over xy. And it's going to be lambda over lambda. And z over x is going to equal 1. And that makes z equals x. And the constraint is that x plus y plus z must equal 190. So x plus, well, y is equal to x, plus z, which is equal to x, is 190. 3x is what? 1/3 of, well, let's do it in 2 stages. 1/3 of 90. Wait a minute. Won't y also be 1/3 of 90? And won't z be 1/3 of 90? What we predicted is true, right? There is only one solution. And that's when all 3 values, x, y, and z, of that guy. Now, the question asks us to write down these guys, right? X, y, and z. But if it asked, what is that maximum value? Wouldn't you just do x times y times z? In which case, what would you get? 190 cubed over 27 and, tidy it up the best way you can. That one went really smoothly, didn't it? So let's pick one that doesn't go smoothly. Let's pick one of the classic questions. How close am I to something? You remember doing those ones? you know, how close or what's the closest point to a thing. So the one I'm picking is question 12. And question 12 is find the point that's closest to 0, 1, 3. And the guy that we're trying to find is this plane. So find the point that's closest to this plane and the point, that point there, right? So can you imagine that's what the plane looks like and there's a point up here. Aren't we trying to find the shortest distance? So I need to set up the two equations. First, this guy here is the constraint. The guy I'm trying to find the maximum value for, well, is the distance from this point, right, to there. So it's going to be x take away 0, y take away 1, and z take away 3, which is the square root of x squared plus y minus 1 squared plus z minus 3 squared. It's a little bit different from the way you did it in the previous section. In the previous section, wouldn't you have turned that z into something to do with x's and y's and worked on it that way? But this is also going to happen here. To make the math easier, I am going to find the maximum value of d squared. Now, if that ends up being 42, then the minimum distance, I should say, if that ends up being 42, won't the answer just be the square root of 42, right? And it's just easier to differentiate when there's no square roots around. So that's very common. So I now have essentially my function that I want to minimize, which is this guy. And it needs to be subject to the constraint that x take away 2y plus 3z equals 6. So, right, now we're ready. Well, the first thing is step 1. Find the gradient of f, and it's going to be lambda times the gradient of g. The gradient of this function with respect to x is 2x. This guy with respect to y is 2y take away 1. And this guy with respect to z is 2 lots of z take away 3. Are we comfortable with that? Fx, fy, fz equal to lambda. Now the constraint function is this guy. So x, y, and z gives me 1, -2, and 3. It's kind of nice. Right. First equation says 2x should be lambda. The second equation says 2y take away 1 should be -2 lambda. And the third equation says 2z take away 3 should be equal to 3 lambda. So I've set up the gradient of f as lambda gradient of g, put in their values and match the first, the second, and the third components. Does that seem okay? Nothing obviously wrong? At this time of night, I definitely need to double check. So if anybody sees something wrong, now is your time to tell me. I'm not saying there's anything wrong. I just want to make sure that it looks good to you as well. Go for it then. Okay. So step 2 says, right, make lambda 0 and see what you get. Well, if I make lambda 0, I get this guy. I get this guy. And I get this guy. And if I solve, I get x equals 0, y equals 1, and z equals 3. Right? 0, 1, and 3. And now I'll check to see if this is a usable answer. Well, x take away 2y plus 3z needs to equal 6. 0 take away 2 times 1 plus 3 times 3 should equal 6. And 7 does not equal 6. So we're gone. Actually, do you know if that had worked? The reason that would have worked is, wouldn't the point already be on the plane and the distance would be 0, right? This point was actually on the plane. So it's not a surprise that that didn't work, but I guess, you know, they could have made it happen. So our next step is to assume that lambda is not equal to 0 and take equation 1 and divide it by equation 2. So that's going to get me 2x divided by that guy, and it's lambda over negative 2 lambda. And the 2's cancel, and I get that. And I believe the lambdas cancel, and I get that. Now, if I do a cross multiply, I get y minus 1 is negative 2x. And that gives me y is negative 2x add 1. Are we okay with that? So I found out what y is in terms of x, which is a goal that we want. Now, if you take equation 1 and divide it by equation 3, you get 2x over 2 lots of z take away 3 equals lambda on the top and the positive 3 lambda on the bottom. The 2's cancel, and you get that. And the lambdas cancel, and you get that. If you cross multiply, you get z take away 3 is 3x. And so z is 3x add 3. And that's good news, right? Z in terms of x. So I'm now going to take that guy and that guy and put them into the constraint and see what comes out. Well, if everything works, all of these 3 terms should equal 6. Well, x is still x. The 2y is going to become negative 2x add 1. And the 3z is going to be 3 times that guy. And the whole thing better equal 6. Okay, time to solve. X, add 4x, take away 2, add 9x, add 9, equals 6. 1, 2, 2, I believe that's 14x. I believe that's 7, and that's equal to 6. So that makes 14x equal negative 1, and that makes x negative 1/14. So we've solved for x. Y is negative 2x add 1. So y is going to be negative 2 times that guy, add 1, which is what? 1/7 add 1. So it's 8/7. So there's y. And z is 3x add 3. 3 times that guy, add 3. 52 take away 3, I think that's 49/14, and that is our z. So I can tell you the coordinates of the point that's closest to that plane. X, Y, Z. And that's what we were being asked to find here, the coordinates. And the good news is, with one exception, because I can't count, that's 39. Everything else is fine. If the question had been, what is the shortest distance? Then wouldn't I go back to here and replace the x with -14, the y with 8/7, and the z with 39/14, and calculate that and get the square root of 82/17, whatever it was. How are we with that one? Okay. Anything about it you are not sure about? If we're good, then I'll move on to our last question. You know they love box questions. We have a box, no missing lid, right? And we are told that the volume of this box is 125 cubic centimeters. And we're being asked to find the dimensions of the box. With the smallest surface area. Okay. I do not know any of the dimensions, so I'm going to call them x, y, z. I know the volume is x times y, z, and so there is my constraint. Now I'm going to create a function that represents the surface area of this box. The surface area is the area of the 6 sides. So, for instance, if you wanted to get the top of that box, it would be x times y, and there's 2 of them. If you want to get the sides, it's 2yz. And if you want to get the other sides, it's 2xz. That function represents the total surface area, right? Top and bottom, front and back, left and right. Are we comfortable with the setup that the constraint is x times y equals z has to be 125 because that's the volume, and that the thing we're trying to minimize is this function here, which represents the total surface area of the 6 sides? Okay, then we are ready to rock and roll. You all know this is going to be a cube, don't you? But we're going to prove it. The gradient of f is lambda times the gradient of g. So that guy there is basically our constraint function. So differentiate this guy with respect to x. You get 2y plus 2z. If you differentiate them with respect to y, you get 2x plus 2z. And if you differentiate them with respect to z, you get 2y plus 2x. Oops, x looks a bit wonky. Now, if you do this guy, you get a yz, you get an xz, and you get an xy. Whoa, just squeeze that in. So 2y plus 2z is lambda yz, first equation. 2x plus 2z is equal to lambda xz, second equation. And lastly, 2y plus 2x is lambda xy, our third equation. And that's step 1 now finished. Okay, step 2. I kind of know this isn't going to work, but for completeness, I'm going to do it. If you make lambda equals 0, you get 2y plus 2z is 0, 2x plus 2z equals 0, 2y plus 2x equals 0. And can you just trust me that 0, 0, 0 is the only way that's going to work? If all three of them are going to be 0 at the same time, the only way that's going to work is x, y, and z are zeros. Now, if you look at the constraint function, x times y times z has to be 125. That clearly is not going to work. So off you go, can't use you. Well, our final step, really. We will assume that lambda is not 0. And I'm going to take equation 1 and divide it by equation 2. And that's going to get me 2y plus 2z over 2x plus 2z. And it's going to equal lambda yz over lambda xz. I guess I could cancel the 2's, I'm just not going to bother. So I'm going to have 2y plus 2z over 2x plus 2z. And the lambdas cancel and the z's cancel, so at least I get that. I'll now do a cross multiply. And that gets me 2xy plus 2yz. And this guy gets me 2xy plus 2xz. Are we comfortable with that guy? Do you notice that the xy's cancel out? So I'm going to have 2yz equals 2xz. I'm going to bring them together. And I'm going to pull out 2z as a common factor. And then I'm going to cheat a little bit. There are two possible solutions here. The first one is z equals 0. Agreed? That could be a solution. Now, if z is equal to 0, won't that box disappear into nothingness? Agreed? If z is 0, that box it actually has no volume. So I know it's not going to work. Right? I'm not even going to check it. I'm just going to use common sense. Right? Z equals 0 is not a choice. That makes this has to be 0, which basically says y equals x, which I like. I'll now do equation 1 divided by equation 3. And equation 1 is this guy again over this guy. And it's lambda yz over lambda xy. And I won't do anything to this side. And the lambdas cancel and the y's cancel, so I get z over x. If I do a cross multiply, if I distribute, do you see that the xz's cancel? And so 2xy take away 2zy equals 0. If I pull out the 2z as a common factor, I get x take away y. We've already went through this. Z equals 0 is not going to work. It's just physically not a solution. So that means that the only other way this is going to happen, did I screw up there? Because I want to see z equals x here. Can everybody see where I went wrong? Because I was expecting z equaled x here.
It should be, you got to factor out 2x.
Oh, okay. That's it. Here, right. From here to here. Oh, I can't factor out 2x. There isn't any more x's to factor out. I don't think that's the reason.
It should be 2xy minus 2zx or vice versa.
Okay, okay then. I'll take your word for it because I'm sure you're right. So if we pull out the x's, we get Right. So if we have this guy and we pull out the two x's, there's the guy I want, right? Yeah, and it makes sense. Well, basically, does it not make x equal y equal z? Right. Y must be z, right? Y and x, they're all equal to each other. And if they're all equal to each other, then we can essentially figure out what x, y, and z are by using the constraint function. Because x times y times z must be 125. And x is the same in each case. So x cubed is 125, which makes x 5, which makes y the same number, which makes z the same number. Hey, guess what? There's the box we knew you were going to get, right? The cube. I don't know if you've raised your hands and yay, it's over, but we're finished, right, Jesse? Yeah, it's a good point, right? There was only 14 questions in that, and I did about half of them, and it took us 2 hours. So you know this is going to be a long homework, right? It's going to take you, if you took the same amount of time as I did, it's going to take you about 4 hours to, to go through all of them. So don't wait till 5 o'clock on Sunday to start, because you won't get the second section done if you do that.